Event-driven architecture, EDA. Event-driven architecture is a design paradigm centered on the processing and handling of events. In this context, an event is defined as a significant change in state or an occurrence recognized by software which can be processed by one or more software components. EDA is highly responsive, making it suitable for environments where stimuli from different sources are asynchronously handled. Now, what are the different components of EDA? First one, we have the event producers. Entities that generate events. They do not know what will happen once an event is produced. Next, we have event consumers, which are entities that react to events. They listen for specific types of events to which they are designed to respond. Next, we have the event channel, the medium through which events are delivered from producers to consumers. And then we have the event processing, which are techniques for responding to events, which can be simple reactions, complex decision-making processes, or event transformation. Now, what are the benefits and drawbacks? One of the benefits is scalability. The architecture allows for easy scaling as components can be added or removed without impacting other parts of the system. We have flexibility. New event types and event consumer logic can be added with minimal impact on existing components. Responsiveness. Systems are highly responsive to changes or user actions as they happen in real time. Asynchronous. Components operate independently and do not block each other, which is efficient for resources. Now, drawbacks. First one is complexity in tracking. Debugging can be difficult because the flow of processes is not linear. Dependency on messaging. The architecture heavily relies on the integrity and reliability of the event messaging system. Inconsistency risks. Ensuring data consistency across services can be challenging, especially in large distributed systems. Now let's look at an example. Consider an online shopping platform that uses event-driven architecture. For the event producer, we have the shopping cart service, which emits an event when a user adds an item to their cart. Now, the event channel, in this case, the event is published to a message broker. Then we have event consumers. Multiple services listen to the cart update event. The inventory service checks if items are in stock. The pricing service calculates the total cost. The recommendation service updates the user recommendations. Then for event processing, each service processes the event independently and takes appropriate actions like updating databases, sending notifications, or adjusting user interfaces. If you have to look at the real world analogy, a home security system acts much like an event-driven architecture, where we have sensors, which are event producers, detect movements or door window openings. The security system, which is the event channel, receives these signals. We have alarms and notifications, which are event consumers, which are triggered in response to these detections. Now, some of the popular use cases for this architecture are real-time user interfaces, where applications where the user interface must update in real time as data changes, such as in dashboards or live monitoring systems. We have IoT systems, where managing and reacting to a large stream of data from IoT devices. We have complex event processing, where applications in finance, security, or logistics that require immediate response to complex scenarios based on event patterns. Now, event-driven architecture is particularly advantageous in systems where it is expected to handle a large influx of events with minimal latency, thereby providing an interactive and dynamic user experience. If you have any questions, please leave them in the comments. Thank you.